back to Area Diesel Service. Today we're going to bring you some new collaborative content with fellow YouTube creator CNC Equipment. So if you've come to us from CNC Equipment, you probably know what this is. This is an injection pump off of a 455E that Clint has been working on in his shop. Clint reached out to us and asked us if we could possibly help him out on this pump. What we know is that this machine sat around for a while, probably 10 years or better. They found an issue with the water pump. Looked like the engine had overheated. They pulled this engine out and have overhauled it, and you've probably seen that content already. When they got this machine put back together, they ran it for a while and it started to white smoke, lack power, and they determined that they have an issue inside of the injection pump. Given the circumstances here, we think what we're dealing with is just a dirty, contaminated pump. It's never good for them to sit around for that type of time frame. We're probably looking at stuck plungers, stuck delivery valve, potentially minor repairs. So open it up, clean everything, inspect, replace any damaged components, new seal kit, whatever else might be needed, run it off on the test stand, paint it up, send it back. This is a DB2 style pump, part number DB2435-4490. So DB2 series of pump, 4-cylinder. The 35 is 350 thousandths plungers. 4490 is the calibration spec, bill of material information. Circa mid to early 90s, suited to a 4-cylinder 276 cubic inch John Deere engine. This particular application is naturally aspirated, so non-turbocharged 276 Deere. Alright, so we've got this pump tagged with Clint's information. We're going to write it up and start a work order in the computer. We'll send this back to the pump shop. They'll disassemble it and do an inspection, clean up all of the components. We'll get a parts list for what we need to go back together. We'll take it into the build-up room, put this thing back together, take it into the calibration room, set it up, run it off, make sure it's delivering proper. We'll give it a paint job, we'll get it back to Clint. We're going to bring you on throughout the process and show you what it takes to get this thing tuned up.
Hi everybody, this is Corey again here today. Today we got this DB2 pump for Clinton at CNC Equipment. I'm going to kind of look over it. I read a little bit of what they have on my notes to see what kind of he was having trouble with, so I have a vague idea what I think might be the cause of it, but I'm going to go into it, see what we got going on, see if we can't fix it up for him. And for right now, basically, he had it mostly capped up whenever it came in. I pulled off a few of the wire seals, stuff like that, no big deal. Put a cap in the end. And I also made note of his fittings and stuff like that so I can send it back out to him the way it came in. So I'm going to go blast it up, get all this old paint off in the dirt, and then we'll come back in and we'll get to tearing down. Okay, so now we got this pump all blasted up. You can see it's quite a bit different than whenever it started. Paint came off very easy, thankfully. Some paint is a real bear and some of it comes off easy, like this pump here. But it'll just make it a lot easier for me now to tear it down. Won't have to deal with all the paint chips getting everywhere, stuff like that, and the dirt especially. So basically I'm just going to start like my other pumps. I'm going to take his fittings off real quick, and then I'm just going to go top down, forward, back, go through that, and we'll see what we find. Okay, so we'll start off with your inlet fitting and return fitting. So we got the inlet fitting out, and thankfully, just a quick thing I've noticed, right here on the back side of his inlet fitting is super clean. So thankfully, that should mean that the rest of the pump is at least clean from a major contamination, something like that. So that's a good sign to start. Take this plug out while we're here, because a lot of times these pumps here have a lot of contamination, and that's a big problem I deal with. See how tight this fitting is going to be. Pretty tight. Okay. Ooh, runaway wrench. Stick this in the vise. Now let's see if we can put some beef on it. There we go. That's better. Put rings off here. This check ball looks clean, so that's a good sign. This is a little idle screw right here. Luckily none of those bolts broke off. Top cover gasket. Solenoid looks okay to start. Everything else doesn't look terrible by any means. Everything's nice and free, so that's a good sign, kind of, I guess. So far I haven't found anything too drastic on why it was doing what he said it was doing. Take these nuts off here. There we go. That's basically it for the top cover. Strip these little grommets off here. So far, I don't normally have too much trouble with these solenoids. Most of the time they do work. So I'm not super concerned that it was causing a problem at this current point in time. Shut off clip off there. Just pulls out. Okay, so this is your torque screw here, which also restricts your fuel. But normally those don't really cause any problem because they don't change any. Technically, he maybe could have tried to back that out a little bit, but if it was working before, it really shouldn't have changed, so there shouldn't have really been a reason for him to try and do that. Okay, that was not super tight, which is kind of interesting because normally, if anything, these are over tight and then it breaks the end here. It splits them out. Springs. Comes up there. It's just a little rubber gasket. Okay, so metering valve is free. Pulled out, but it does have a decent amount of wear, so that might have been hurting them a little bit, but maybe not quite to the extent that he was saying. And then we will pull out the bent screw. This wire looks good. This piece here actually, this controls all your return, so there's different numbers of these vent screws. It goes from a 0 to a 5, and 0 is the smallest wire, which lets the most amount of fuel through, and a number 5 is the biggest wire, which lets out the least amount of fuel. So that is a simple way you can kind of regulate that, but normally whatever it comes in with, it normally goes out with, because it's not a thing that changes a lot, especially on a pump like this, because this pump here has a more mechanical auto speed advance rather than some of the other DB2s that have a light load advance, where the light load advance is actually has a servo piston inside of the housing, where with this one being this style advance, it runs in the piston caps. So it's a slightly different design. These don't normally wear out to a super extent, unlike the servo style pistons. They wear out quite a bit, honestly, and they will create problems if you let them wear out too much. Then your advance just won't work right, then which could lead to lots of smoke or something like that. This timing cover. Luckily everything is nice and clean, so that's a big help. That's your advance adjuster. Let's pull it out. So, I'll take off this end cone here. So in your end cone, that's basically all there is to that, but then you have, this is a spacer ring in a sense because there's different styles of these. And his filter, honestly, has quite a bit of crap on it, which is kind of surprising, honestly. Can't quite tell if that's just plain dirt or if it's rust particles or what it is, but it's definitely, it's not packed by any means, but it's far from clean. So that might be a leading problem, but I can't say that would restrict the fuel enough to really cause a problem. This is your transfer pressure adjuster. So this regulates how much transfer pressure you get at different speeds. This has a little screw here. Little surface plate, spring. This piston normally wears out, which this one is. It has quite a bit of wear to it, which that's a part that I replace basically 99% of the time. And this has a little bitty O-ring right here. Takes a sharp pick to get it out. Put that O-ring out. That's basically done. Here's your liner and blades like any other Stanadyne pump, which these blades have a fair amount of wear to them, honestly. Which again, that's another part that I replace basically all the time. It's just easier to replace those than it is to worry about them later. And another sign right here is he has some more dirt or rust or something inside of here, so that's kind of concerning in a sense. So we'll take this out while we're here. It's your cross shaft for your governor arm. That's what this actually pivots on. If you don't take both sides out to start, you can push the rod back and forth and it'll get these O-rings out easier. And once you get one side of the O-ring off, then the other side will just pull out. It's a trick of the trade, if you want to say that. This cross shaft has a little bit of wear, but nothing concerning. That looks fine. Okay, so down my advance. There we go, that'll be easier. It's just a plug, an O-ring. Then I got the socket. There's a little slide washer on there, which that just pulls off. That's your spring piston and your advanced springs, and then your adjuster that's in there. That little plate there actually is what your springs sit on. If that plate wasn't in there, then you wouldn't be able to adjust your advance. That wasn't super tight either. Perfect. It's a little trick. If you tap on the back of these caps, and your piston normally will pop out. Little piston ring. Try and do this without breaking it. There we go. So that's good. Get this little O-ring. This is your power piston, and same way with your spring piston. These have different numbers on them to represent how much advance you get. So, like, this is honestly a short power piston, so this one probably moves quite a bit more than normal. His spring piston's around average length in a sense, so I would say, if I was to guess, this probably gets around 7 degrees of advance, if I was just to guess off the top of my head, but I could be completely wrong too. Now to get the cam screw out. I lost my socket, there it is. That'll work. Perfect. So that came out good. Normally you don't have to worry about these too much. Every once in a while the threads will pop off or it'll split here on the end, but that's not terribly common. Pull that out. O-ring ripped, but that's normal. Whenever you pull those out. Check ball's free, that's good. So now basically all we got left is just to pull out the head. This is just a spare shaft I have. This will make it easier to pull this thing out. Just put it right through the middle there. Grab my rubber mallet. Went. So there it popped out. Let's work it out. Okay. So here's your thrust sleeve, your thrust washer, and your weights. Which nothing looks too worn out. That maybe has a little bit of wear, but not enough to cause a problem. That never wears out. Okay, basically we're just down to the head left, 'cause that's basically all there is to that. Peel the nameplate off and I'll have to push this pilot tube out, but that's normal. The snap ring off here. Okay, so I looked at this breakdown previously, and it was supposed to have a solid weight cage, which I've talked about in a previous video. So this one here has a flex ring, and as you can see, this thing is broke in 3 spots here. So thankfully, it's not broke enough to where it was plugging the return connector. However, it could have been causing some irregularity in his governor. This one is pretty well still held together, so it probably wasn't causing too much of a problem yet. But if it would have kept going and he would have kept running it, then he would have definitely had a problem later on. So thankfully he honestly caught it early, because a lot of guys will keep running it, and what'll happen is it'll absolutely destroy these tabs, which I'll show you. Pull these off here. So that just comes apart. So normally if the flex ring is really broke, it'll wear down these rivets here to a point where it's literally unusable. It'll wear it down so much that I had one the other day where this pin was just being held on the inside, and I could dang near pull it out. So it's just from keep running it while that flex ring is broke, and just trying to get the most out of it whenever. Really, I'd say it's probably better to fix it earlier than it is to fix it later, in a sense, because then, you know, that's probably one of the more higher priced common parts I replace, so that's, you know, can save you a little bit of money if you just go to replace it earlier rather than later. So cam looks good. That would have been another thing that I would have been worried about since he was complaining of low power, is that there are times where these cam lobes, instead of being an actual, you know, hump, it'll literally flatten it out. And once it gets flat, then it just won't have the pumping power that it was whenever it's from the factory. So thankfully that's good. His rollers and shoes look good. Pushes. So those are nice and free. So that's good. This is the leaf spring. We're not going to mess with it right now. It's to number 1. There's a 0 through a 3. 0 gives you the least amount of fuel in a sense, and the number 3 gives you the most amount. Just to give you a rundown of that. Pull off the retaining clip. I leave this on till now because I found that if you take these out, which you can whenever the head is still in the pump, then what happens whenever you go to try and push it out, what could happen is that the head part can literally pop out before the rotor. So then it goes flying and stuff goes everywhere. I find it's just easier to hold it together and then take it off now while it's apart. This helps protect everything because, you know, that, especially this part is very sensitive. So if you bend one of those, it's basically ruined. You can try and bend it back, but most time if you bend it one way and try and bend it back, it snaps. And, you know, that's $1,000. So I just don't take the risk. Got our delivery valve screw. All that looks good. Another thing that could have been causing a problem is that if this delivery valve spring was broke, that could cause it to be low on power. There it went. And this delivery valve has quite a bit of wear to it, which isn't uncommon. Again, it's another part I basically have to replace every single time. So that's nothing that I'm super surprised about. Otherwise, this looks pretty good. Has a little bit of wear, but nothing crazy. Let's see if I can see anything. I don't really see anything like a hole being plugged up or anything, so overall, as I would have it sitting right now, I would say even though that he has changed the filters and everything, it still had some contamination in it that it came from somewhere. So whether something else is plugged and it went through it, I can't really say. Whether he has something else down the line that maybe isn't 100%. But overall, the pump itself wasn't terrible. I didn't see anything drastic that I'm like, okay, yeah, that's the problem. So I might be able to find a little bit more once I go to run it. You know, I might be able to see, okay, yeah, it was a little bit under fuel, under stock, or whatever. I might be able to tell then. But as it sits right now, it's just a normal, you know, normal parts being worn out, stuff like that. The reason why I separate them is because if the internal parts are super nasty, then I'll throw them in the sonic cleaner and it'll help clean all that out. Basically all the steel parts, and basically everything in my other basket is aluminum parts, and any part I'm going to replace anyway. So, or like the bolts on the outside, they don't necessarily have to go through the sonic cleaner, so I just separate them. A lot of the other guys don't. It makes really no difference, but I just organize them like that. So I'm going to finish cleaning this up, push this pilot tube out, give this another blasting, get all this stuff out of here, make it cleaned up a little bit better, and then we will order parts and go to rebuild it. So that's why you gotta press that out. You know, to blast that to get all that glue out.
you can load this ratchet. Huh?
Yeah, and luckily it's not really going to take that many parts, so we should have everything. Okay, so now we got it all set up here, got it cleaned up, got my tray laid out kind of how I like to do things, got it all kind of organized so that way it's a little bit easier for me to build it. So we are going to change the 2-piece weight cage to the 1-piece, which is right here. So instead of it being that, you know, it's one solid piece. There's technically cushions in here, but rarely does this style ever wear out, so we don't really have to worry about that anymore. However, I will have to change his timing mark from this one to this one, so I'm going to use my degree wheel here in a minute. I'll show you guys that, and then I'll have to scribe a new line on there. Otherwise, right now what I'm going to do first is I have a brand new pilot tube. Any pump that we have that requires a pilot tube basically gets a new one every single time. Rarely ever do I reuse a used pilot tube. It's just one of the things. It's easier for me to use a new one, so I know that it'll work for the customer. It's not going to create any problem there, and I don't have to worry about it anymore. It's just easier for me. So I'll do this first so we can wait on that to set up some. Mix up some 5-minute epoxy and then we can stick that in there. Get the outside of this pilot tube mostly covered up, especially in these grooves, and you don't want it to be anywhere on the inside. I did already make sure this pilot tube fit before I tried mixing my epoxy, because sometimes they are a little tight and they don't like to fit in there. Wipe off some of this excess. Now I'm going to use my tool. This tool is set up for 2 different depths, so since this already has a flange on it for the O-ring groove, I gotta use the small depth one to set that. That is a predetermined depth. If it didn't have this flange, I'd use the deeper side and it would just stick out more. So that's done. Now we can wait for that to set up. While we're waiting on that, we will go through some of these other processes. So on your rotor here, you have your stop seat in there. There is a stone that you can regrind that to make sure you don't have any grooves or anything in it. I normally do it regardless, but you don't necessarily have to do it. If you stick a new stop in there and it doesn't leak, then you don't really have to worry about it. So I got a brand new delivery valve. I just spray some 104 on it. This is just a degreaser just to make sure that it's clean. Got our delivery valve spring, which was his original one. Then got a brand new delivery valve stop. So that all fit in there good. Normally I like to lap these delivery valve screws just to make sure that they're nice and flat. There we go. Then I have to torque this to a specified torque, because if you go too much it could seize the pump, and if you seize that head, then that is a big price tag. Make sure your torque gauge is zeroed out. Okay. So that's torqued in there now. This is just calibrating fluid. Just to lube up the outside of the pump, of the rotor there. I have already buffed some of these parts. Like I buffed the outside of the head here, I buffed the end cone, and I buffed his 2 fittings just to make sure everything was nice and clean. So that fits in there nice and smooth. I will put on my head O-ring while I'm thinking about it. These are his pumping plungers, so I'll stick these in. I normally put the wear point to the inside. Does it make a huge difference? I can't really say it does, but that's just something I do. Okay, so those are nice and free like they're supposed to be. If they're not free, you always should make sure that they are free, because if they stick at all, then they could cause a low power situation. Okay, so those are both in there. Now I'm going to take my handy dandy homemade fitting. This time I'm going to hook air pressure up to it to make sure that stop is not leaking air. Because if it's leaking air, then it'll leak fuel, and if it's leaking fuel, then it might not make cranking. So make sure my plungers are popped out, which they are. Put a little bit of calibration fluid in there. Which I do not see any air bubbles in there. So that is a good sign. So, while we're here, I'm going to clamp this in the vise here. So I'm going to check the roller roller, which I have got that. My roller roller spec is on my breakdown, so I know where it needs to be, which I have it wrote down. 67. So this will tell me kind of where he had it set at, which actually that would be. So technically, right as it sits right now, he would be 7 thousandths over stock spec. So he should not really be having any problems with fuel, from the head at least, because normally 7% over is around 10%, roughly speaking. Guarantee that varies depending on where the head and things like that, but as it sits right now, we're not going to mess with it. Put your cam ring on next. Of course, you have your arrows pointing in the direction of rotation. So this is a clockwise pump, so it'll go in the clockwise direction. We already checked the cam earlier for any abnormalities, whether it be chips or things like that, so it is good. But before we put our weight cage on, we have to put our timing mark on. So I'll set that off to the side. Grab my degree wheel. So, like I said, this is my degree wheel. I have to put this on in a certain way to make sure that it will actually line up like it's supposed to. And again, I got my timing degree mark spec from my test sheet, so I know what it's going to be set for. This particular one is 131.5 degrees, so I have to follow the direction of the arrow as it goes, which with this one being a brand new weight cage, it does not have any timing mark on it. Okay, so I got it lined up here, got my wooden pencil, so I'm going to double check. Yep, 131.5. Put my line. So that just gives me a reference line. Then I will go over here, squeeze that lightly, and I'm going to use this fancy all electric pencil here. Let's grab my line with it. Looks pretty good. I like to keep it within at least half a degree of spec, which we are perfect. So that right there, at least now I know that A, it has a timing mark, and B, it is correct. So that is done. We can go back and we have to line up the point here with our mark on our rotor. If you put it the other way, it'll be 180 degrees out and it won't work. Put our snap ring back on here. Okay, so that's on. Flip it over. Put your O-ring in the, it's your end cone O-ring, if that's what you want to call it. I always make sure it's pushed all the way down, just to make sure it doesn't bind up or not seal or get cut, something like that. Something that I don't want to have happen. Put our retaining plates in. Technically, on some of these, like these ones here, you can flip over and you can put the non-worn side up. Some of them, there is a variety of these. It's more in DB4s that you cannot flip them. So these ones we can flip, so we'll put them in the other way. Whether or not it really makes any significant difference, I don't know, but I'd rather do it and it not make a difference than not do it and have it make a difference. So this is a reman liner that we do here. Put that in. Have brand new blades and springs. First two have to go down and the other two have to go above. I always just put a little bit of fluid in here just to make sure it's basically lubed up. Have our regulator now. We have to put our O-ring back in there, and then we'll put our piston, our spring, and our adjuster in there. It's a little square O-ring. I always put it in from this side because I find it to be easier. Use a pick to push it down in the groove. Make sure it's not twisted or anything. Okay, so that looks good. Brand new transfer pressure piston. I said his was worn out, so couldn't reuse it, which normally I don't reuse them. We have our transfer pressure spring and our adjuster. This style here, I always just put it flush to start and then I adjust it on the stand whenever I run it. So okay, so got our adjuster. I put his filter through our sonic cleaner, and now at least it's all nice and open, and so that way I know it's clean. Stick that on there with our little filler plate. Make sure it all lines up here. Then take our end cone here. Have some grease. Put it right along the bottom edge here. You don't have to put a ton of grease on this. Just enough to where that O-ring will hit it. I just do it kind of snug for right now because I'll have to torque that in later once I get this on here. Okay, so this is all nice and clean. My pilot tube has had time to set up, so I don't have to worry about it slipping out. Okay. This particular DB2 does not have the drive shaft held into the pump. Most DB2s have a drive shaft that's held in with a clip on the inside. This particular one does not have that. The drive shaft stays with the engine. It was not sent in with the pump, so it's a little bit different how it goes together, but for the most part it's the same. Basically, I always put your governor arm in here first, because I find it's easier to do this now before you get the head in. So get your pivot shaft, put it in through the hole. There we go. Okay, so now through both holes. Put our brand new O-rings on each side. Try and make these as even as possible. That don't look too bad. Okay. And take your little cap nuts. Make sure they're clean, and I put a little bit of grease on the end of them. Grab my little socket tool here. Again, you want to try and get these turned in as even as possible, but then you want to tighten the right side last, because that turns your pivot shaft up. So that's good. So now, make sure my holes are clean in the housing. It is. If that hole is plugged up, then your advance won't work. Put a little bit of grease on the inside here, so your head will slide in easy. Turn that down like that. So now I will put my weights in and line everything up here. With this thrust washer here, I always put the least worn side down, because the toe of the weights is what makes all the wear. So you want to try to avoid putting the wear side down. This one here was about even on both sides, so it didn't really matter as much. Make sure all your weights are in correctly. Okay, R. Then I will stick it in. With me having a pump vise, I can angle it down easily, so that way whenever I put the head in, my weights don't fall out. Just screw in your two head bolts. Just finger tight right now, because your bottom one has to be torqued in first. So, this metering valve I'm going to change, because it has a good amount of wear. That's partially why. This is just a junk head. Obviously you can see the head is seized, but I just use it to change out my metering valve arms. Just like that. Switch out the arm. You want to make sure that it's tight, because if it's loose, you don't want it to pop off while it's in the pump. So, put my shim washer back and spring back on. So that's nice and free, because that's inside the pump. Going to put our vent screw in here. Look through it and try and see light through it. Make sure that it's not plugged up. There we go. This doesn't get torqued in, it just goes in till it's snug. You don't really want to crank on it. Yeah, that's good. So, now I will this is again just a dummy shaft. It's not the one that goes with the pump, but it again helps keep my weights from falling out. So now we're in a spot where it's a little bit easier for me to work on it. This is your head locating screw, has a little check ball in it. You want to make sure that's free. This one is. This is just a little seal sleeve. Put my O-rings on. Okay. Put some grease on these. Stick that in there. I'm just using a ratchet just to make it a little bit quicker to go in, but you have to torque these in. Okay. Torque wrench. Torque this into the specified spec. Then while I'm here, I'm also going to torque this in now, since it's right here in front of me. If this isn't torqued in enough, you won't make transfer pressure. But if it's torqued in too much, then it could seize the head. So it's fairly important to get that torqued in correctly. And then also while I'm here, we will put in our cam screw. That also has to be torqued in. So this is a special bit that's made for these. If you use a normal like T45 bit, it'll split it every time. So, and this is like a stabilizing bushing. So that way, whenever you go to torque it, it doesn't snap off your cam screw. Torqued in there now. And you want to make sure that's free after you torque it, because sometimes it'll kind of twist the cam a little bit and it'll make it tight, but normally if you just tap on it, it'll free up. So we have our power piston cap, our spring piston cap, and then our respective pistons. Your power piston needs the square O-ring. Again, you want to put it on here, make sure it's not twisted. Take a pick and roll it over if need be. That looks good. Your piston ring back on. Then I have a special tool. It's a little piston ring compressor. Part number has to go into the cap. So that fits in there just like that. Put our new O-rings on here. Not the right one. Our new O-rings, put some grease on them. Just put a little bit of grease there just to hold this slide washer. And the power piston always has to go on the side of rotation. So this is the clockwise side, being that this is a clockwise pump. So I'm just going to hand snug that for now. Put our new O-rings on this. And have my adjuster here. Pull the old O-ring out. And I need to make sure that it's free. Ooh. Just make sure it's free now so that way it doesn't cause me any trouble on the stand, which this one is kind of tight. As you can see, it's kind of rusty, so okay, that should be good enough. I shouldn't have to adjust it much from that, so that's okay. Grab a new O-ring. Some guys do it differently. I always put the adjuster in there and then put your little spring seat on there. But some guys put the spring seat on the springs and then put the springs and everything in the cap and then screw the adjuster. It's all just preference. There's no real rhyme or reason to it. Put your spring piston with your springs in it. Again, put a little bit of grease on the end for the slide washer. Stick this in the pump. Special wrench for this. You technically use a socket like I did to pull it out. Okay. It just honestly has to be tight. There's no real need to torque them in. Okay. So then basically all we got left is our plug in the bottom. Tighten that down. You don't want to over tighten that too much because you could strip out the threads in the housing. Once you do that, the housing is basically junk. So, everything seems to be according to plan so far. Everything on. So, put your governor spring, spacer, well idle capsule, well idle spring, and your little cap there. Put that in. This style here takes a little rubber washer. Put that on. And just snug that down because if you go too tight, you'll pull the threads out of the housing. This is my torque screw. This is an old style housing, which the torque screw goes here, which goes straight in. The new style come in at an angle and use a different style torque screw. They both work the same, it's just one's old style and one's new style. It's kind of tight right now, so I'm going to try and see if I can get it freed up. There we go. And we'll find an O-ring for this. Put your grease on there. I always make it so that way it's not really doing anything to start, because I don't want it to be affecting anything currently, because then I'll set it on the stand later. Yeah, that'll work. Okay, so we're down to all this parts now. I leave the O-ring on this whenever I tear it down, so that way I don't lose this little washer here. Some of you may wonder why I did that. Put your new O-ring on. Grease. I leave this out for right now because that's where I'm going to read my transfer pressure whenever I go to run the pump. So I got my throttle lever here. Didn't really do anything with this, just washed it up. Made sure that my spring was good. Seal sleeve right here. Got a brand new O-ring. Some grease. Put this back on the way it came out. Okay, so that's working so far. Put another spacer on this. Might not be able to use. I basically use those little clear white plastic spacers as ways to get rid of the end play, which if you go too tight, then it can also cause problems like this one was. I'll take that back off. Okay. I'm reusing this clip, so I just tap it a little bit just to make sure it's going to be tight whenever I go to put it back on. And then I just use a tool like this to put it on with. And make sure everything spins free, because sometimes if you tighten this, then it'll lock everything up if like you use a different liner. Sometimes it'll do that, so I always double check that. Everything seems to be working. I'm going to check this linkage gap. The reason it looks a little wide. Oh, nope, okay, so it's in spec. This is just a little gauge here, so it has different measurements, and I'm supposed to be in between 125 and 165, which this one was at 165, so I'm not going to mess with it. If it was too big or too small, then I'd have to go in there, just a little screw, and then tighten it or loosen it, and that would change it. So I pulled the grommets off earlier. I did test this earlier and it did test fine in here, but we'll still obviously try it while it's on the stand. Stick these grommets on here. I always use a pair of side cutters to put them on. Seems to work the best. So, here's our top cover. We cleaned it up, we blasted it, make sure there's nothing in the O-ring groove, which there isn't. Stick those through, put your insulators on so it doesn't ground out on the housing. Fin washer. So those are nice and snug. Okay. And this is missing a washer, so yes. Okay. So your little locking nut here. This is your ground strap. Basically just put everything back on how it came off. Okay, it's good for now. Put my O-ring in here. Then before we put it on, we'll put on our low idle screw. That one's going to be stiff, so. Again, I left this O-ring on here earlier so that way this washer wouldn't fall off. You gotta make sure everything's free. I'll have to adjust this on the stand. And if he needs to adjust this later, he can. Where if it was stuck, then you either have to take it out completely or mess with it then, and that's just not good. I do not. Some grease on there. I always just put it flush with the inside of the cover to start with, and then I'll set it later. Okay, that's basically it for right now. I'll throw this on here. Got our bolts. Which I'm going to add another couple washers. Okay, so basically all I got left is my return connector and then stamp my serial number into it. So O-ring for this. This was cleared out. This is his original return connector. I just made sure it was nice and clean. Okay. I'll read that off because that's how I read my advance on the stand. I'm not going to put his fittings back on right now. So, now all I got to do is just stamp my number into it, and then it'll be ready for the stand. Okay. Basically now this pump is ready to be ran, so I'll get this pulled off and we'll get it set up on the stand and we will run it off and see if it works. Okay, so I got this pump on here. I was getting ready for it to warm up, let the fluid warm up, and try to get it started. Well, come to find out that even though I tested the shutoff solenoid in the room, once I got it in here on the stand, it's pulling basically too much current and it's not working correctly. So that is a fairly significant issue. So basically now I just got to pull this off. Luckily I can do it right here on the stand. So I'm going to pull this off, pull my solenoid out, switch it out, and then we will see if that fixes anything. Okay, so I got me another solenoid here, so I will pull this old one out. I did test it again in the room, so we'll see if that will work for us. Normally I don't have too much trouble with these solenoids, but every once in a while you get one that doesn't work. see if it'll work. You can hear it clicking there, so this one is definitely working. Maybe still seeping a little bit, but it'll be fine. Okay, so I'm going to run it here for right now and get this thing warmed up because it has to be warm in order to be a accurate test. So I'm going to let this run and then I'll come back and we'll actually start our test. Okay, so just kind of give you guys a little rundown here. My pump is warmed up now. So this here is my advanced gauge. You'll be able to see this go up and down as I change RPMs. And that just tells me how much my advanced pistons are moving. Whether this pump here gets a total of 7 degrees. So that's kind of what I thought in the room, but now we know that at least by full load it's supposed to be getting full advance, okay, which is pretty normal. This here is my transfer pressure gauge, which is reading how much pressure the pump is producing to run like the advance and to feed the head. So then we have our high pressure lines going to our injectors, which then feed up through my metering unit and then give me my readout on my computer here. So then this will tell me my fuel delivery, RPM, temperature, stuff like that. And then basically I got my solenoid hookup and my return gauge. So that kind of gives you a little bit of a rundown of the mechanics of the stand in a sense. This is a Bosch 815 stand, which is what I basically run all my Stanadyne pumps on. We have other stands here, but for these, this is basically the only stand I use. So I'm going to get after it here and make some adjustments and try and get it to fall into where it needs to be. So to start off, my transfer pressure is too high, so I have to turn that down to get it closer to spec. Technically, just like a lot of things, it's better to have it a little bit high than low, but also you don't want to have it too terribly high. about 10 to 12 pounds high, just for reference. Which if it's too high, then if it goes way too high, it'll seize the pump. But if it's just a little bit high, then it affects my advance movement. So if you get it closer to spec, then your advance is going to fall more into spec. Perfect. So as it sits right now, the pump is about 15% over stock spec. So I originally thought in the room that it might be closer to 10. We're a little bit over that. So power-wise, these should have plenty of power. Now I'm checking cranking. Basically, I always check my main fuel and then I check my cranking next, because if my main fuel is in spec or like 10% over, but then I go down to cranking and it doesn't pass cranking, then basically that tells me that the head is bad. Because you don't want to go, I could keep going up and eventually probably get it into spec if it wasn't. But at some point you have to tell the customer, like, hey, your pump is physically worn out. So sometimes you have to be realistic with them that say, hey, we can get it to work, but it's not really something that may not last. Because this one here is making good cranking, so. Which the more cranking fuel you have, the easier it is to start the engine. One of those things, Stanadyne pumps run half of engine speed. So if you're cranking, if your low idle is set at 700 RPM, I only run the pump at 350 RPM. So if you watch it and then you go, oh, well, that's running pretty slow, well, that's the reason why. Well over my minimum spec, so shouldn't have any trouble starting, shouldn't have any trouble with power. Now I'm going to go through, check my advance, and set my high idle and my low idle and do things like that. minor adjustments there, but now my advance is in spec and it's working properly. I always like to speed it up and slow it down a few times whenever I'm setting my high idle to make sure it's set correctly. basically just give a little rundown there. After I set my advance, I went up and set my high idle, which is basically your max RPMs, and then came down to my full load, checked it, and this is a torque screw, so basically he was making too much fuel at his full load, so basically as I turned that in, it dropped my fuel delivery to get it closer to spec. So with that being all set, check the solenoid, it's working great now. So at least now I know that it'll shut off once it gets on the engine. And basically all I have left is to set his low idle, which I'm going to do now, and then basically the pump will be done. This pump here, it has low idle screw in the top cover. So some of you guys might have a pump where it has a screw on the lever. Well, same with like this one here, it has a screw in both places. Well, if it has a screw in both places, the screw on your lever is your throttle stop screw, not your low idle screw. If it has a screw in the top cover like this, that is always your low idle screw. So, if your tractor's running a little slow or a little fast at low idle, you have to set it there. If it does not have it there, then it is on the lever. Okay, so now basically with that low idle being set, that was my last spec. And other than the solenoid failing, didn't really find much else wrong with it per se, but did find that his head was set up a little bit high. So now if he gets it back and he's still having problems with it, then he can kind of go a different direction of looking into the tractor. But that solenoid definitely could have been causing him a problem. I can't say it's 100% his problem, but is maybe definitely contributing to it. But as it sits right now, I'll basically pull it off, finish it up in the room, and then paint it and send it back to him. Okay, so I got it back in the room here. I'm going to cap it up, put some wire seals on it, just for technical sake. And then I'm not going to reuse his caps. I'm going to put some actual red caps on it, but then we'll paint it and go from there. So also put his fittings back on. Wrenches. That's over there. Okay, so now we're ready for paint.
Alright, so there you have it. Cleaned up, disassembled, inspected, upgraded, repaired, calibrated, painted, tagged, ready to go back to the customer for another cycle of life. So what did we find? Initially, upon teardown, not too much. No smoking gun here. So miraculously, for having sat for 10 years, the inside of this pump was remarkably clean. A little bit of debris on the inlet filter. We did find that the flex ring was cracked, but it had not yet started to deteriorate. We did upgrade this unit to the solid style weight cage retainer, eliminating the flex ring. That update is not mandatory, but it is one that we consider a worthwhile cause. And we could tell that someone had been inside this pump before us. We found that the pump had been turned up a little bit over stock fuel delivery. But overall, this pump was in pretty good shape. So what did we do? First thing we do, clean them up. We want something that's a little bit easier to work with. Then we completely disassemble and inspect the pump to try and get an idea of what's going on with it. Throw away all the consumables, seals and gaskets, and clean up all of the subcomponents. Then we'll make a parts list for everything we need to go back together. In this situation, metering valve, delivery valve, gasket set, pilot tube, one-piece weight retainer, and a name tag. Reassemble the pump back together, inspecting everything again as we assemble it, and then put it on the test stand to calibrate fuel delivery and ensure that the governor is working correctly. And as you saw, that is where the issue with this pump presented itself. So the problem with this pump was in the electric shutoff. This pump has a 12-volt solenoid under the top cover, and when you provide that solenoid 12 volts, it turns the pump on and allows it to provide fuel to the engine. When you disconnect 12 volts from the pump, springs shut, shuts off the supply of fuel to the pump, and the engine will die. Now this solenoid was working to some degree on the engine, but when the engine got up to full operating temperature, the solenoid must have lost its capability to do its job, and you saw the machine start to lack power. The solenoid more than likely got weak and was allowing the pump to sit in some mid shut-off type of position. Alright, so the million-dollar question, what did it cost? Now, I would tell you to take this with a grain of salt because every pump repair is going to be different. Prices can climb dramatically if we get into a higher level of hardware replacement, specifically head and rotor and the pump housing. Or if any of these subcomponents have to go back to the machine shop for service, the price of the repair will increase accordingly. This overhaul was $817.69. So that is 5 hours of labor and the parts that we previously discussed. So that answers our number one most popular question and comment. Again, keep in mind that is for this pump and that is for today's price. Your results may vary. So we can give you kind of a ballpark range of what you should expect, but it's really impossible to quote a pump repair without knowing first what we're going to be repairing. But know this, we're honest, we're fair, we're qualified, and we stand behind our work. So there you go. If you haven't already been following along with this resurrection project, please go over and check out CNC Equipment on YouTube. We'll give you a link to their channel below. They've got a lot of excellent content over there regarding construction equipment, service work, auctions, Jeeps, and whatever else type of stuff they get into. And you can go over there and watch this pump get reinstalled on the engine and put back into service. If you found yourself here from content on Clint's channel, we appreciate you stopping by. We're just getting started with our YouTube channel, so if you like this type of work and content, please consider subscribing and leave us a comment below to let us know how we're doing. If you find yourself in a situation where we can help you, please let us know. We do a lot of pump repairs, turbocharger overhauls, injector work, but we do a lot of other things we haven't covered on YouTube yet. Engine rebuild kits, water pumps, starters and alternators, particulate filters, EGR components, engine sensors, and we take great pride in servicing our customers with the highest level of quality service we can provide. And we'd appreciate an opportunity to earn your business. If you need to get a hold of us, you can call us at 800-637-2658. That one phone number rings all of our locations in Illinois, Indiana, and Iowa, where you can get immediate access to a diesel engine expert. You can email us at parts@areadiesel.com, or you can log on to our website at areadieselservice.com, where you will find a tremendous amount of quality information and the ability to chat instantly with a diesel expert through the button in the bottom right hand corner of your page. Or you can mail us a letter, send us a fax, or stop by any of our locations where we can meet you with a handshake and do some in-person business. Whatever is most convenient for you. If you do need service work, and if you let us know that you learned about us through this collaborative effort with CNC Equipment, we'll take care of getting you a shipping label to get your component to us, and we'll hook you up with a pair of Area Diesel Service mechanic gloves. Boom. So that's it. Thanks for watching.